Siemens' vision is that for any battery of today or tomorrow, we want to empower battery companies or companies across the whole value chain in their engineering, manufacturing, and operations of those batteries. And our aim is that we want to bring digital transformation to these companies so that by connecting real digital world where they can explore new concept, optimize designs, and meet it connected with the real world where they are manifesting those designs in actual manufacturing. So bringing that digital transformation by connecting digital world with real world, that's where we are focused on. That's Siemens mission, and it is strategically critical for Siemens to empower the industries in achieving that, because we ourselves, Siemens as a company, we are committed to sustainability goals. And for us, it's not just about meeting sustainability goals in our operation. We want to empower the larger industry in achieving their sustainability goals. And to us, sustainability is not an add-on at the end. We always say that Siemens, that sustainability needs to be part of everything that you do. So how you design a product needs to be sustainably done, so that there, if you're doing less testing, relying more on simulation, digital twin to design that product, optimize that design, you are becoming more sustainable. How, when you are in a production floor, um, how can you uh, reduce the weight of robotic heads, right, through additive manufacturing, right? That, and if you think of how many robotic heads are there, be it of battery manufacturing or any other manufacturing, that reduces the electricity consumption. You become more sustainable. When you look at the operation of a factory, one factory or multiple factories, how um, companies can optimize the energy usage, optimize the energy consumption in their factories by being more efficient in their operation, by managing their energy consumption, optimization of that through the combination of automation technologies, through the combination of data analytics. So all of those things are critical for any company to become more sustainable. And of course, bringing that circularity, uh, best practices. So when you're designing a product, can you design it in a way that it can be recycled later? So design for recycling, right? And how in the case of battery, for example, if you look at recycling, one of the big problems with recycling is disassembling the battery pack. It's a manual process. Um, so we are bringing, Siemens is bringing the power of AI and the technology so that companies can disassemble those packs more efficiently. They can discharge down those batteries to 0 volt quickly, so that they can be more efficient at recycling. So all of those things, when you add together, um, you become more sustainable in a scalable way. So for us, it's important that we exercise those sustainability practices in our own operations, in our own business practices, but also deliver those values to our customers so that they are sustainable from the conception of a product design. The top three challenges industries facing when it comes to battery recycling. Before I answer that, I just want to put it in context. If you look at lead acid batteries, they are all, more than 90% of lead acid batteries in the world are recycled. If you look at lithium-ion batteries, roughly 5 to 7% of lithium-ion batteries are recycled. And it's, of course, when you look at the EV, so you can say the vehicles that went on the road in early 2010 timeframe, they are about to come out of end of their life. So the we are about to hit a very big wave of recycling. Right? So far recycling has been a little bit lower scale, but in next couple of years the scale is gonna come very fast. So so when you look at in the historical context, can batteries be recycled? Absolutely. Lead acid batteries recycling has paved the way. When you look at lithium-ion batteries, they haven't been recycled because the scale has been lower, but now we are about to move in that direction. In terms of challenges, I would say there are three challenges. First and foremost, collection of batteries, where the end of life from consumer bringing it to the recycling centers. There are a lot of logistics involved in that. So having um, a regulatory framework, the way it has been done for lead acid battery, will be very helpful to collect those batteries and bringing them to recycling. Second thing is the overall recycling efficiency. Right now, it still is a lot more costly, and at least when you look at the large scale. And companies are working. There is a lot of innovation happening in that on how to improve the recycling efficiency. But definitely, that is a key area to look at. And last but not the least, also is um, re- more than recycling. Many industry needs to look at it more holistically. Is it always business friendly to do recycling, or should we be looking at some reuse cases? Because when you look at electric vehicles, when you say the battery has come to its end of life, there is still around 70% of energy left in the battery. So given that, and given the cost of battery cells are coming very significantly down, there is a strong argument in terms of whether you should be recycling those batteries or should you be reusing them for other purposes. It can be like energy storage for residential application, or other application where they can be utilized for. So those are the areas that the whole industry needs to look at, especially now as the supply chain challenges are becoming more prevalent. There is also there's a impetus from industry to, especially from the battery manufacturers, that how can they use more recycling even during the production process, because there's a lot of scrap that comes during battery cell production. Rather than discarding all that scrap, can they extract materials out of it, so that then they are increasing more and more of the used materials rather than the new material that they have to get. So it's a combination of challenges, because some technical challenges, but also the business landscape is just evolving, and the fact that with the geopolitical and the tariff situation, supply chains challenges, is also encouraging companies to look in that area. For Siemens, we don't make batteries, but what we are doing, as I said, we are providing solutions, um, so that the companies who are in the battery value chain, who are whether producing materials or cells, or taking those cells and making packs or using them in a system, whether that system is a car or energy storage, how they can how can then do that at scale, at lower cost, or at the right cost and the right quality. To do that, our emphasis is, again, as I said earlier, is how companies can front load a lot of those decisions that they can make early in their design and their production scaling, rather than waiting for all the machinery to come on the floor and then make the changes. An example, if you think of a factory layout, or you're putting together a pilot line or production line, um, we have seen that when if they can simulate the whole behavior of how the machine is going to come, how the material is going to flow, how the AGVs are going to go. If they can simulate all that, they can design the factory layout correctly. They can make sure all the machines are going to come, and the flow of material and is going to be optimized. That and also that allow battery suppliers to work with the machine builders to make sure their machines is going to come and fit it in their ecosystem in the right way. If when companies don't do that, it's a big hassle, because you get a lot of those machines, and now you have to make some of the changes, which can be very costly and time consuming if you have to do it at the last minute. So adding that value, bringing a lot of those decisions early, helps companies save that time and cost, so that they can reduce 20-30% of cost, improve production efficiency. And the other thing that we are also focusing on is what we call data driven manufacturing. And the point is, um, If you look at battery manufacturing, it has been even today very experience driven. I mean, if you look at some of the large battery makers, they have perfected their manufacturing operation, optimized them based on doing and based on hit and trial and experience that their workforce has built for them. But there are issues, of course. If you are a new company, you don't have the luxury of time of 10, 15 years to build that experience based optimization of your manufacturing practices. But even the companies who have that experience, the question is that experience going to translate if when the material changes, when the chemistry changes, when the manufacturing processes change, or if you take that manufacturing operation from one country and scale it up in another country? We have seen that that doesn't scale. So how companies, both new companies but also the existing companies who have been doing manufacturing for many, many years, how they can use data coming out of your factory, data and insights about how different machines work, how the manufacturing process is working, and the power of AI in data analytics, how they can combine all of that to find the problems quickly, and how they need to be solved quickly rather than relying on the experience of a few folks. And those are the things that we are focusing on. And again, that's where we are bringing our digital twin, our automation technology, how automation technologies and digital twin can work together with power of generative AI, data analytics on the factory floor. We are putting all of this together, working with our customers to help them reduce their scrap rate, help them improve their quality. And as I mentioned earlier, that when we have deployed some of those things at some customers, we are seeing tremendous improvement that they are able to make, like 10% reduction in scrap rate, because they are not just relying purely on the experience. They are able to marry some of their experience and knowledge with the data and the insight that are coming from the factory. So that's where our focus is in making the battery production more scalable for the world. We look at this Southeast Asian region very strategically important, because of course you say China, Japan, Korea, they are the powerhouses. That's where the center of gravities are today. All the large battery suppliers are here. There's a lot of demand for electric vehicles. But if you go to countries like India, Malaysia, and the larger Southeast region, there are also a very strong adoption curve for electric vehicles. But those vehicles are different. A lot of them are what I call like two-wheelers. So for having electrification of two-wheeler is a very different challenge economically, the design and manufacturing and again the overall operation compared to a four-wheeler. Right? Same way, there is, and the other dimension is looking at a lot of these countries are looking to electrify and with large trucks and buses. Right? So there's a lot more public transport that they are looking to electrify. Very different use cases that they need to deal with. And if, for example, if you look at India, they are investing a lot in renewable energy. Um, but then if you have any renewable energy, you need to have energy storage. So a lot of opportunity, a lot of specific use case that these countries are going after. They are building that some of the ecosystem in-house, but also they are looking to learn from the best practices that are happening or happen in rest of the world. So a lot of those companies, I look at them as very digitally native because they are not carrying the legacy burden. So they are willing to move very fast. They are digitally native, and excited to try and test different things, and that makes it exciting for us to also work with them in a different way, and their growth mindset that they're bringing to catch up fast with the leaders in this world. So again, as I said, Southeast Asian region critically important for us, and that's why a lot of focus we are putting in these regions to help the companies to build and the countries to build their ecosystem. In our leadership, if I look at my Siemens CEO Roland Bush and our management, they are always being a voice of change voice of sustainable development in the world, and they are working with our management is again many times engaging with the leadership of various countries to influence them and be be an advisor, being an industrial company ourselves. We are always open to share our best practices, or what are the best practices we are seeing that the other countries and companies can benefit from. And there are various organizations we are also participating, consortiums and advisory bodies that we participate on. So yes, we look at it as a being one of the leaders in digital twin, being leaders in automation technology. We think it is our duty to help countries adopt these technologies fast for their sustainable growth. So when it comes to our own product development and R&D, we have a very distributed footprint globally. I mean, of course, we have a lot of people who are focusing on product development. So that's all distributed. It's in US, Europe. There are certain things that we are also doing in Asia Pacific region. So yeah, we have strong presence both our expertise wise, our product development activities, R&D activities all across the world. Helping companies to scale their production to giga scale is one of the missions that we have, and we have been working in this with um, startups. A lot of the startups we have worked with, so that it's help them to scale up their production. We are working with large enterprises who already have large scale production gigafactories, and making it helping them make it more efficient, increase their throughput and quality, and scrap rate, reduce scrap rate. So absolutely, this is, and that's where we are bringing, as I said earlier, the power of digital meets real and how it can help. What is also unique about Siemens is that we have our own factories in some of like some of our other business units make um, motion control devices, so some electronics for industrial applications. So we are not only just preaching things on piece of paper, we are also implementing those practices in our own factories. So one of our factories is a lighthouse factory. It has been judged by World Organization. So again, our perspective is we are practicing those things internally in our production facilities, and learning from that experience, and then of course disseminating that through our portfolio, our products, our digital tools, our automation technologies to the world. So again, for us, it's not just about telling others, but also exercising and showing that this is the art of possible when it comes to improving the production throughput, or how you can make it more sustainable. I mean, if you were to crystal ball gaze, right, I mean, obviously the pace of technology change is so rapid now. So where do you see the industry maybe, let's say, in 5 years? Yeah, it's a great question, but before I answer the question, I'm gonna just put it in perspective. So when I started in the battery industry, um, I was working at General Motors. It's in 2008 time frame, and that time the battery dollar per kilowatt hour on an average was around $1,000 per kilowatt hour. And I remember sitting with my fellow researchers and engineers and talking how 60 kilowatt hour battery was impossible to think of when your cost is $1,000 per kilowatt hour. Your battery of 60 kilowatt hour will cost more than a car. Come to 15 years ahead today, the battery costs $100 per kilowatt hour average. Right? So you see, I mean, more than 90% reduction in cost in the last 15 years, thanks to the work that industry and everybody who's involved in the industry have done in the last 15 years in through the improvements in manufacturing, reducing costs, taking scale. And also in these 15 years, the energy density of battery, means how much energy you have per kilogram of battery, has gone up 3 times. So in 15 years, the industry has shifted tremendously thanks to everybody who has been involved from academia, from industry, from research, production, and everybody. Everybody has made tremendous contribution to get it to this level. It's a C shift. When you say 90% reduction in cost, three times improvement in energy density, but this is just to set the stage. Okay, the pace of innovation is going to continue. So when I say where the industry is heading in next 3 to 5 years, I would like to. I won't be surprised if 5 years from now, when we are at the end of this decade, starting next decade, that not only the cost is even down, we'll have likely to have a lot more new technologies to improve energy density to a level that and energy and also they're going to be charged fast, right? So the this question of range anxiety perhaps will be we will be much closer to the ideal solution, and also we are likely to perhaps knock on the door of electric aviation. Just to put in perspective, a magic number for electric aviation, at least the short route, um, battery to have around 500 watt hour per kg energy density. Right now is close to 300. Right? So the yeah eVTOL, a lot of companies are investing, but if you look at the short distance air travel, we are not ready for electrifying that. But the pace that industry is going forward, the new materials technology, the new designs of cell and pack and safety, making it safer, as it is moving, I won't be surprised that will be knocking at the door of initiating electric aviation, at least for the short distance aviation. So, and again, to achieve that, not just lithium-ion battery, but new battery technology like solid-state battery perhaps will advance a lot more. Sodium-ion batteries, which are already in early stage commercialization, and it is very likely that in the next 5 years we'll see a lot of that becoming part of energy storage and a lot of other applications. So yeah, in summary, I'm very excited uh, for what is in store for in next 5 years, where the next decade is going, then where we'll be starting the next decade, and I won't be surprised that. So today we are talking about EVs and battery energy storage. I won't be surprised come 2030 we'll be saying, okay, maybe electric aviation is around the corner, and I won't be surprised if we will be talking not only about lithium-ion batteries but the new chemistries beyond lithium-ion.